The number that we are about to subtract from 4 has 2 places of decimal. We therefore need to write 4 also accompanied by 2 places of decimal. In doing this subtraction, we do not approach the entire thing blindly, and mathematics is surely a subject that requires that we exercise a certain amount of foresight and that we also plan ahead of time. We have here 4 minus 2.95. Because we have 2 places of decimal here, we need also to write 4 accompanied by 2 places of decimal. We will then place the other number below 4 with the decimal point vertically aligned as usual. Then we may proceed to subtract. On the next slide, we will carry out the subtraction process. We need to begin by saying 5 from 0, but we cannot do that. We cannot take 5 from 0, so we go to the next column. And what do we have in the next column, which is this one? Another 0. There is another 0 there, so we move to the other column, which is this one. Therefore, by that time, we should be all the way over to the extreme left. Use 1 from that position and bring it to the less significant position. So use 1 from here, we will have 3 left to the less significant position. So a digit from the more significant position is 10 times the digit in the less significant position. In mathematics, we are always, if we are going from right to left, we are always increasing by powers of 10. So neglecting these points, we'll have 10 to the power of 0 here, 10 to the power of 1, then we have 10 to the power of 2. Considering that the points are there, and they really are there, then this would be 10 to the power of negative 2, and this will be 10 to the power of negative 1. Therefore, the digits that we have in a particular, if we are at a particular position, the digits that we have to the left will be 10 times the place value of the one that we have here. Therefore, the one that we are using from this column taken here will be 10 times the value of the one that we have here. Therefore, instead of a 1, we have a 10. From this position also, another digit is sent to the next position with the same effect, because what we intended to do initially is take 5 from 0, which we cannot. Therefore, we went all the way to this column only because we did not have anything supplied here. So no doubt we need to take this all the way to the least significant digit. So we remove 1 from here, we are left with 9, and then we have another one here which is 10 times its value here, and we have 5 to subtract from 10. So 10 minus 5 is equal to 5. And then we have 9 minus 9 is equal to 0. No doubt the point goes back as before, vertically aligned with the others, and we say 2 from 3 is equal to 1. 1.05. There is a close analogy between this problem and another one that we have solved on a previous slide. we will take the same steps to count the number of decimal places in both numerator and denominator. So we have 0.28 1.05, but we will count the number of decimal places 1, 2, 3, 4, and in the denominator we count 1, 2, 3, so we have a slackness of 1. The numerator has 4 and the denominator has 3. Do what it takes to eliminate 4 places of decimal, that is, multiply by 10 to the power of 4, which is equal to 10,000. We will pay special attention to the denominator because it only has 3 places of decimal. We have chosen to eliminate 4, that is 4 decimal places. If we focus on the denominator and only eliminated 3, we would have another 1 in the numerator that we will do well to eliminate. Although in primary school we did not bother about decimal places in the numerator, but now we are attempting to eliminate all decimal places altogether. So 1, 2, eliminate those 2, and we will also eliminate another 2 right there, a total of 4. In the denominator has only 3 decimal places, therefore we will use a 0 to account for the missing 1 right there. So 2, then we will eliminate the other 2, and we will be ready for our division. Let us go straight ahead and reduce the fractions. Those that are familiar with the multiples of 7 would have recognized a few of them there. 14, 70, 28. Those who are not will learn some of them in this exercise. 14 divided by 14 is equal to 1, and 28 divided by 14 is equal to 2. We are reducing by a common factor of 14 right there. 70 divided by 35 is 2. We are dividing or reducing the fraction by a common factor of 35. And of course, 105 divided by 35 is equal to 3. And we see those 2 in the numerator and the denominator. 2 into 2 is 1, and 2 into 2 is 1. The result is 3, and there is no difficulty seeing that the result is 3. In solving this problem, we will make use of the fact that multiplication and division take precedence over addition and subtraction. Then proceed to complete the multiplication operation first. So here we have 2.55 multiplied by 6.3, and we are subtracting 7.5 over 1.25. But we are saying that division and multiplication take precedence over subtraction. Therefore, we will do the multiplication process and the division process first. So let us go straight ahead and do just that. When multiplying numbers that have fractional parts that are given in terms of decimal fractions, we multiply the numbers as if there is no decimal point. In the end, the answer will have the same number of decimal places as the total number of decimal places of the numbers that are being multiplied. In this case, the points do not need to be vertically aligned. The least significant digit of the multiplier will be used to multiply the multiplicand, beginning at the least significant digit. And this might be a little more than a mouthful, but the demonstration thereof will make it very clear. We will multiply 2.55 by 6.3, and we will begin to multiply the numbers by taking the least significant digit of the multiplier, and we will multiply the entire number here beginning at the least significant digit. So we take the 3 5s, 15. Write down that 5 and carry 1 as usual. Then what do we say? 3 5s, 15 again, but there's another one that we need to add. So 15 plus 1 is equal to 16. Therefore, it is 16 that we are using. So write 6 of the 16 and carry 1 to the more significant column. Then finish up by saying 3 2's 6, and 6 plus 1 is equal to 7, and 7 goes right there. We will now move to the more significant digit in the multiplier. Since it is greater in significance than 3, the first digit in the significance will be greater than the first digit in the previous answer. So since 6 is more significant than 3, or is greater in significance than 3, when we multiply 6 by 5, the first digit will be greater in significance than the first digit that we have here. So if we say 6 5s, 30, what do? Write 0 and carry 3, but the 0 will be placed under the 6, showing that the first digit in the answer is greater in significance than the first digit in the answer that we have here. So place the 0 there. This number that we are using on this occasion is greater in significance than this 3. Therefore, the first digit in the answer will also be greater in significance than the first digit in the first part of our multiplication. Carry that 3. Then we say 6 times 5 is equal to 30, and we cannot neglect this 3 that we have right here. So plus 3, 30 plus 3 is equal to 33. We write down the 3 and we carry a 3 to the next column. Finally, we say 6 2's 12, and 12 plus 3 is equal to 15. There we have it. Some may want to include a placeholder 0, but they will do this at the beginning of the process. There's your placeholder 0. But I guess most teachers will teach that the placeholder 0 be placed first. So after multiplying by 3, you put a placeholder 0, and then you begin multiplying by 6. Let us add the numbers in the two products beginning with the least significant digit, which is the 1 to the extreme right, as usual. So no problem adding to 0, 5, and 6 with 0, no doubt will give 6 also. Here we have 7 plus 3, that is equal to 10, and we write 0 and carry 1 to the next column. Then what do we say? 5 plus 1 is equal to 6. And we have nothing to add with this one. It goes back as it is. But do we leave our answer like that? No. We do something else. What do we know? The total number of decimal places in the multiplicand and multiplier together is 3. So we have 3 places of decimal here. The answer will therefore also have 3 places of decimal. So the number of decimal places in the product will be the same as the total number of decimal places in the multiplier and multiplicand together. We have 3 in total. The answer will have 3 decimal places in total. We will begin the division process by first clearing the decimal places from both numerator and denominator, because we have done the multiplication here. Before we subtract, we'll have to do the division also. So let us go straight ahead and do that. What do we know? 2 places of decimal, and we need to throw in 1 in the numerator. The denominator had 2 and the numerator had 1. We therefore needed to include an additional place of decimal in the numerator, and that we have done in order that we may compensate for the slackness that we had in the numerator. Notice that in mathematics, even in mathematics, we eliminate slackness. Therefore, no doubt we should eliminate that in also every other sphere of our lives. The point trailing all of the digits does not affect the value of the number. So in each case, we eliminate that point. And then we may go straight ahead and reduce the fraction. So we are saying reduce by a common factor of 25. 125 divided by 25 is 5. And 75 divided by 25 is 3. And what do we do? Do not neglect this 0. Include it also. And then we may take it a step further, saying 5 into 5 is 1. And 5 into 30 is 6. And to be quite honest, it is not far-fetched to see that some candidate may just look at that and tell that 750 divided by 12.5 is equal to 6. Or maybe it would be easier seeing it from here, but it does not matter. Some candidates may be able to just look at it and realize that this one is 6 times this. 125 is related to 12.5, and 12.5 is half of 25. So 25 into 75 is 3. So 12.5 into 75 should be 6. And there's no doubt that that should not be too much of a difficult process, because 12.5 is a popular number in mathematics. 12.5 is what? Well, 12.5% is 1/8. 25% is a quarter. So we realize that 12.5 should not be a number that is well beyond our grasp. Now, what we need to do is subtract 6 from 16.065. Even the blind can see that subtracting 6 from 16 is 10. Therefore, subtracting 6 from 16.065 should be 10.065. However, there is none so blind as those who will not see. Let us therefore place 6 below 16.065, considering that in a whole number the point is at the extreme right, and we will also vertically align the points. So put 6 right there, and the points will be vertically aligned. So the point is at the extreme right in that whole number, which is 6, and it should be vertically aligned with the other. Throw in some placeholding zeros, right, and we do the subtraction process very quickly. We are subtracting 0 there, and if we subtract 0 again, it is the same number that we are going to get. And even if we subtract 0 from 0, we will still get 0. Right. The point will no doubt go back as it is, and then we say 6 from 6 is 0, and then we put that 1 down. And some of the candidates are very happy that that is the case. We have 10.065. We do not assume that you look at it and get the answer alone, but we have demonstrated how we may get it, and you say, oh, it is as simple as he said. But before the process, some students block their minds to it, and it is only at the end then they are saying, oh, I should have done it that way. Right in my mind, make use of whatever brain cells we have left in order that this problem may be easily solved. We also need to write that number correct to 1 decimal place. In order to write that number correct to 1 decimal place, we first need to identify the position where we have 1 decimal place. Locate the first decimal place, the first digit to the right of the decimal point. So that one is to the right of the decimal point, and that is our first place of decimal. In order to write the number correct to 1 decimal place, we also need to check the digit that is next in order of significance, the one to the immediate right, and that is the one that we are looking at also. That digit is 6. Because it is greater than or equal to 5, we therefore add 1 to the 0. So 1 will be added to this 0 because this number is greater than or equal to 5. So there is the 1 that we have added to it. And what do we do next? The digits to the left are not affected and return exactly as they are. Therefore, our answer is 10.1, as we have right there. As usual, trailing zeros after a decimal point are not necessary, and especially in this case in which we are required to write the answer only to 1 decimal place. We do not need another. We are at number 6, and we have this large fraction bar again, and we discussed before that we need to do all the operations here and all the operations here before we nicely combine them into a simple single problem. So we will add first the numbers that we have in the numerator. So we put the first one down, and for the second number, ensure that the points are vertically aligned and write the digits on both sides of the point. So 8 will be on the right hand side, and on the left hand side we have 38, and we are about to add them, and the question is placeholding 0. Alright, put that placeholding 0 there, and then we add the numbers beginning at the least significant digit. Sometimes when I'm adding, I do not begin at the least significant digit. I look at all the digits first and realize that it can be simply added, then I just go from left to right. But if we are doing things the correct way, showing the underlying principle, then we will begin at the least significant digit. So 2 plus 0 is equal to 2. 3 plus 8 is equal to 11. So we put 1 down and we carry 1. What about that point? It is vertically aligned with the others. Align the point in the answer with the others. We have done that. Then we say 8 plus 6. And do not forget the one that was carried from the previous column. So that is 15. We write 5 and carry 1. And then when we add all of those up, the 3, the 2, and the one that was carried, we get 6 and 65.12. The numbers that we have to subtract have the same number of digits and the same number of decimal places. We need to subtract these. Same number of digits, same number of decimal places. Alignment should not pose a problem. So we just write them down. No problem with the alignment there. If we write them vertically below each other, then we should have no difficulty. Then we go straight ahead and say 6 minus 6 is 0. And then we say use 1 because we are intending to say 5 from 1. Cannot work. So we need to use 1 from the position that we have here, the most significant position, and bring that to the position that we have right here, which is of a less significance than this one. So 3, 2, and down here a digit from the more significant position is 10 times the digit in the less significant position. So it will be here as 10, and 10 plus 1 is 11. So we will be subtracting 11 now. So 11 minus 5 is equal to 6. And the point is vertically aligned. And we move merrily to 2 minus 1 is 1. And then we do not have anything here. 1 minus 1 is 0. And what do we say about that 0? That leading 0 does not affect the value nor the validity of that number. So we do not have to put that one in. This process that we are about to carry out has now become one of our favorites, removing decimal places. On this occasion, the slackness is in the denominator, and we will eliminate the slackness here also. 1, 2. $16 we are dividing into 160, and we are assuming right away that 16 can go into this one also. So we say 160 divided by 16 is equal to 10, reducing by a common factor of 16. There we go, 10. And then we say 16 into all of that, but we do not take it all at once. We say 16 into 65 is 4 times, and remainder 1. We say 16 into 11, and the 16 cannot divide into 11 a whole number of times. So 0 time in terms of the number of whole numbers. Therefore, we do not move yet. We put a 0 there, indicating that it cannot go into the 11. Then we extend it to 112, 112. So 112 divided by 16, and that is equal to 7. And it is good that we have 10 here. So 407 divided by 10, and that is equal to 40.7. When the problem is in decimal form, one might want to leave the denominator as a power of 10, although it was not possible for us to reduce this one further right here. So when the problem is in decimal form, one might want to leave the denominator as a power of 10, maybe 10, 100, or 1000. This makes division easy when we just have to reduce by a number of decimal places. So I'm sure that we can remember that we had 1 to divide by 100, which is, of course, I can remember 36 to divide by 100. We already have it over here, and we ended up with 0.36. Therefore, we got here and we are dividing by 10. So 40.7 makes it easy when we are dividing by 10 or 100, especially when we have problems in which the answer, in which the initial statement had decimals. Then it is good if we can write our answer in decimal also, and by so doing we will opt to leave the denominator as a power of 10 so that we can reduce by a certain number of decimal places in the end. 40.7, 407, 40.7 is our answer. When we have to reduce a fraction with numerator 6512 and denominator 160, we should anticipate that 16, being an obvious factor of 160, should also be a factor of 6512, but not necessarily. We are just assuming that it should be, because it would be good if we can find a large common factor, reduces the fraction very quickly. So we see 160, obviously a multiple of 16. So let us say, alright, it would be nice if 6512 were a multiple of 16 also, but not necessarily. But it would be good if it turns out to be, well, we know that it turns out to be in this particular case, but I'm saying generally that will not necessarily be the case. Now, since the number divided down to 112, let us look at it again. Right here, 112. It divided down to 112. Since the number divided down to 112, we may make a rough check to see if 16 is a factor of 112. And then bingo, everything is as we imagined. Everything has a successful end. So let us go straight ahead. Make a reference to something that we know, like some multiples of 8. What are the multiples of 8? I'm saying that we can just make a rough check. I'm just putting a structure to it, and the structure may take a few seconds, but in your mind this thing can be done in very, very short period of time. So make a reference to something that we know, like some multiples of 8. 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 88, and 96. Multiples of 16. Not surprising. For the most part, there should be no difficulty working out the multiples of 16 if we know the multiples of 8. Since 16 is twice 8, the multiples of 8 are 8 units apart, and the multiples of 16 are 16 units apart. Therefore, every other multiple of 8 is a multiple of 16, provided that we begin at 16. So if we start here, every other one is a multiple of 16. Every other one is a multiple of 16. And no doubt, 96 is one of them. I always imagine that multiples that are less than 100 should not be so astonishing. The last multiple of 16 within that range is 96. 96 is 4 units away from 100, and 112 is 12 units away on the other side of 100. So 4 plus 12 is equal to 16. Since 112 is 16 units away from a known multiple of 16, it is therefore a multiple of 16. Now, this is something that is taking quite a few minutes just to explain. But when I'm taking a look or try to identify if 112 is a multiple of 16, I quickly know that 96 is a multiple of 16. And to get from 96 to 112, that is 16. Therefore, 112 must also be a multiple of 16. So it does not take me any long time. But I'm throwing in the multiples of 8 because you can make, or most students will be able to make, a reference with the multiples of 8 in order to arrive at the multiples of 16. So that's what caused, on this occasion, or for the purpose of this presentation, the multiples of 8 to be necessary. But otherwise, I would just go to 96 because 96 is the largest multiple of 16 that is less than 100. And from 96 to 112, that is 16. So for sure, 112 is a multiple of 16. Therefore, we may go straight ahead and reduce the fraction by a common factor of 16. We are about to multiply 0.03 by 1.3. When multiplying numbers that have decimal places, the answer will have the same number of decimal places as the total number of decimal places in the multiplicand and multiplier together. What does that mean? That means that we need to multiply these without considering the decimal places or any decimal point. So multiply the numbers as if there is no decimal place. So we will multiply 3 by 13, and we know that that is 39. No problem there. 3 times 13, 39. That is a breeze. Now, there are 3 places of decimal in the problem. The answer will have 3 places of decimal also. However, the product only has 2. We will include a 0 to complete the trio. So the product has 2 digits, but we have 3 decimal places here. So we need to throw in another 0 to complete the trio. And please do not put the decimal place to the right of the 9, because some students will do it. Put a 0 here instead of there. Now, what would be incorrect about putting the 0 here is that when you place the point right here, then the trailing 0 is of no significance. It does not affect the value of the number. Maybe just the number of decimal places alone. But in this particular case, the number of decimal places will be instrumental in concluding about the actual value of the number. Therefore, we have to be aware that the decimal place, the additional one, should be to the left of this digit, and then the point will also be further to the left. it is appropriate to place a 0 to the left of the decimal point. So 0.039. In this second part of number 7, we have a subtraction component and a multiplication component. The number preceding the brackets without any arithmetic operation is assumed to be in a multiplication relationship. Multiplication takes precedence over subtraction. However, brackets take precedence over multiplication. We will therefore perform the operation that is inside of the brackets. First, we have subtraction inside of the brackets, 6 preceding the brackets, meaning that we are multiplying by 6. Multiplication takes precedence over subtraction, but the brackets will take precedence over the multiplication, and we will perform the operation that is inside of the brackets first. The number that we are about to subtract from 3 has 2 places of decimal. Because of that, we will need to write 3, also accompanied by 2 places of decimal. We have 1.47, 2 places of decimal here. We have to plan ahead, catering for the 2 places of decimal in the number that we are about to subtract, by also include 2 places of decimal in the number that we are subtracting it from. So we will then place the other number below 3 with the decimal points vertically aligned. No problem. On the next slide, we will carry out the subtraction process. Now it is time for us to subtract, but we need to begin by saying 7 from 0. We cannot take 7 from 0, so we go to the next column, which is this one. There's another 0 there, so we move to the other column. So by this time we are at this column, where we use 1 from that position and bring to the less significant position. A digit from the more significant position is 10 times the digit in the less significant position. So we have 10 there, because the one that we take from this position will be 10 times this one. As we know, as we progress to the left, each time we go up 10 times. From this position also another digit is sent to the next position with the same effect. So we cannot be comfortable or be satisfied unless we go all the way down to this first position here and have something from which we can take 7. Turns out to be 10. So 10 minus 7 is equal to 3. And 4 from 9 is 5. The point will go back as usual, and then we say 1 from 2 is 1. Let us finish up by performing the multiplication operation. The multiplier will be used to multiply the multiplicand, beginning at the least significant digit. So 6 3s 18. Write 8 and carry 1. Then 6 multiplied by 5 is equal to 30. Cannot neglect this, so add 1 to it. The 30 plus 1 is equal to 31. Write 1 and carry 3. And finish up by saying 6 ones 6, and 6 plus 3 is equal to 9. The problem has 2 places of decimal. 2 places of decimal are in the multiplicand, and we do not have any in the multiplier, so we just only have 2. 2 plus 0 is 2. The quotient will also have 2 places of decimal, 9.18.